So here's another example of an annuity. So it's again a story problem. So let's read through this to understand what the coded words are that we need to solve the problem. How much would you have to deposit each month into an account that earns 4% interest compounded annually if you wanted to have $20,000 in 4 years from now? Your first deposit will be in 1 month and will last 48 months from then. So the question then becomes, okay, so what are the required information that's given to us and what do we need to solve for? So you can see how much would you have to deposit each month. So that's the code for the cash flow itself being the unknown in this case. So we need to solve for what is going to be that equal monthly cash deposit that we will have to make in order for us to have $20,000 4 years from now, assuming monthly compounding. Okay. So but the interest rate that's given to us, the 4% interest, is the annual rate, it's the APR. So the first thing we have to do is to convert the interest rate into its effective monthly rate, which is simply taking the 12% interest rate and calculating the monthly rate from there, which is 0.04 divided by 12, which will give you the monthly rate, because your periods are monthly. So 48 or 4 years is going to be 48 months. So you have 48 months, but given that these are annuity payments, we're really looking at monthly payments. The number of payments in this annuity stream is 48. So that's the 48 that you need. And then you also need the fact that the interest rate, the monthly rate from the annual rate that you're given is 0.0033. So if you calculate those things and put them in the formula, the future value factor for annuity, or like I said, you can simply look it up in a table where you'll say n equals 48 and I equals 0.0033. If you have a table that gives you the factor for those sets of interest rates and n, then you're in good shape. The problem is that for non-standard interest rates, you're not going to have tables that will give you those. So in this case, it's a non-standard interest rate, right? 0.0033 is not a 1%, 2%, 3% kind of thing. Therefore, you're not likely to find a ready-made value for the factor from a table. And that's why I insist knowing the formula always, or having, worst case scenario, have a financial calculator, which will do the same thing for you, assuming that you already understand what you're doing, which is the key thing here. However, substituting in these numbers into that factor equation, future value factor, you get 1 plus 0.0033 raised to the power 48 minus 1 divided by 0.0033. That's a straightforward substitution of values in that formula. Then you get the cash flow is the future value divided by the factor, which gives you $385.22 as your equal monthly payment. You have to make 48 of those starting a month from now in order to have $20,000 at the end of 4 years at the growth of interest that's given to you. So that is the answer to the problem. And you need to make sure that you go through it again slowly to internalize all the concepts we've talked about so that this becomes second nature to you. Good luck.